Hey AAF students, welcome back. We're going to get started before I even talk about what we're doing this lesson with a quick review of what you did in class. So you learned long division with polynomials, right? And so in this quick review, the first thing that we're going to do, and this might be a great place to pause it and try it, is we're going to actually find the quotient of this, right? So the quotient is the result when I do division, and I'm going to use long division for this. So I'm going to go ahead and I've got x cubed. I'm missing my squared term, so I'm going to write 0x squared so that I don't forget it, minus 13x minus 12, and then I'm dividing it by x plus 5, right? So x goes into x to the third, x squared times, let's multiply it out, x to the third plus 5x squared, subtract and bring down, just like you did with long division without polynomials, right? Without variables. This will give me negative 5x squared. Bring this down, minus 13x. That goes in there, minus 5x times, negative 5x. So that will give me negative 5x squared minus 25x. When I subtract, the purpose behind that was for those to cancel, and then I'm really doing negative 13 plus 25, right? So, or 25 minus 13, I can also think about it as, so that's 12x minus 12, and that's going to go in, what, 12 times? And so I've got 12 times x is, oh no, I ran out of some room. Okay, 12x plus, what is 12 times 5? That is 60, right? 12 times 5, yes, 60. And when I subtract, I'm doing negative 12 minus 60, which gives me negative 72, right? So that did not divide evenly. So my quotient would be x squared minus 5x plus 12. And there's a remainder, right? So plus negative 72 over x plus 5, right? Remainder over divisor, right? So this right here is my quotient to what I was given, okay? So to answer these two questions down here is x plus 5 a factor? No, it didn't divide evenly. Well, if x plus 5 is not a factor, then x cannot equal negative 5, right? That's not a solution to this. So what this means is if I took this cubic function that I started with, one of my, I can't factor out x plus 5. This isn't divisible by x plus 5. So negative 5 is not one of my x-intercepts, is what that's determining, right? It's not going to be one of my zeros. No, if x plus 5 is not a factor, x is not going to equal to negative 5. Okay? So it's not one of my zeros. So that's what you learned in class. What we're going to be doing in this lesson and then building on the next time we see you is that we're going to use info/graphing technology. There's going to be a lot less of this than we traditionally do in a classroom, but that's okay. To identify any real zeros of a polynomial, followed by synthetic division, which is different, right? It's not long division. We don't want to forget long division, but it's a little different. And you're going to learn that right now. To completely factor or solve, there's a difference between the two, a polynomial, right? So that's like number one. There's objectives in this. The other objective is that we're going to use synthetic division, same thing above, so this is new, to determine if a given linear factor, think about what that means. What's a linear factor? Right? You can have quadratic factors, cubic factors. We're talking about linear factors here. Is, in fact, a factor of a given polynomial. Okay, and so this is really important that when we're dealing with this thing called synthetic division, which you haven't learned yet, we need linear factors. When you're doing long division, sure, you can divide by a quadratic, you can divide by a cubic, you can divide by anything, right? In order to do this synthetic division, we're going to be doing just linear factors. That's all you can do. So let's get started. Synthetic division. It's not really dividing, right? It's an algorithm that's going to get us the same result as dividing, but it's not really dividing. Okay, so it generates the same answer as division, but it's not really division. So just, you don't want to, this isn't in the place of it. It just has a different use, and it will be, sometimes this will be used. Uses the zeros of a polynomial function, uses the zeros. Okay, so think those are the answers, right? So like I have a 0, the x-intercepts. So like x equals 3. That's what we need. We need like linear zeros. We don't want anything that's quadratic. Not factors like we did in long division, right? Long division, you need the factor. Like you're dividing something by x plus 3 and you're determining if it's a factor. Here we're working with the zeros. Okay, so given that 2 and negative 3 are zeros of this polynomial, we're going to use synthetic division to generate all the zeros of this function. We're going to copy down the coefficients, right? So I'm starting with the 4th degree, 1, 1, negative 5, 1, negative 6. If I was missing any, right, just like I was in that warm-up, I'm going to put a 0 in its place. I can't just drop it. There should be 5 because it's a 4th degree polynomial and there is a constant. Choose one of the zeros and write it to the left of the coefficient. So my two zeros, if we back up, were 2 and negative 3. You can pick either one. Okay, I'm going to pick 2. Draw a line under the coefficients and bring down the leading coefficient. So that 1 is going to come down. Multiply, write down, add. Sorry, I clicked too much. Multiply, write down, add. 1 times 2 gives me 2. So I multiplied, I wrote down, and I'm going to add. There's 3. Do it again. Multiply, write down, add. Multiply, write down. So 1 times 2 is 2. Add 3. 3 times 2, multiply, write down, add 0. This right here are the coefficients of the degree 3 polynomial, right? I got rid of one of the zeros, so it went from a 4th degree to a 3rd degree. This 0 right here, whatever number here, is, well, I told you that these were zeros. You were given that they were zeros. If you were trying to confirm they were zeros, this number might not be 0. But this right here is your remainder. Okay, so in this case, because I told you it was a 0, the remainder should be 0. Therefore, this value should be 0, that last one. So we can keep going, right? Let's go ahead. I've now reduced this to a 3rd degree, a cubic function. So now I'm going to go ahead and I'm going to use my other 0, this one, negative 3, to keep going. So I'm going to drop my negative 3 there, and then I'm going to do the same thing. I'm going to draw a line. Oops, sorry. Bring down the leading coefficient. Multiply. Write down. So 1 times negative 3, 0. 0. 1. Negative 3, 0. This is what I wanted, right? So I now, right here, have x squared plus 0x plus 1, or I have x squared plus 1. Does this factor anymore, right? If it did, this would be a really good place for me to factor. If I wanted to solve, this would be a really good place for me to solve. Right now, I can re-express this. I basically have x minus 2 times x plus 3, right? Take my zeros and write them as factors, times x squared plus 1. These are equivalent, right? These are both p of x in factored form. I could tell you that I have 2 real solutions, and then this one's going to be what? Plus or minus I. Right, if I use the 0 product property there, x squared equals negative 1 square root, we get plus or minus the square root of negative 1, which is plus or minus I. Right? So let's see. We're given some information. We're given that x plus 3 is a linear factor of this. And we're going to go ahead and use synthetic division to generate all of the other linear factors. Sorry, I got ahead of myself. So I'm going to use that. -3, let's write down our 0. It doesn't use the factor, I need the 0. I've got 1, 0, -13, -12. Why is that 0 there? Because I have a plus 0x squared. Don't forget that. Let's go ahead and bring down the 1. Okay, so when I do this, it's going to reduce it to a quadratic, which I should use some of my background knowledge that I have from Unit 4 and Algebra 1. So multiply, -3, write it down, and add. Multiply, write it down, -13 plus 9, what is that, 4? -4. Multiply, this is 0. So it worked, right? If it didn't work, then this statement wouldn't have been true. So I've now got x squared minus 3x minus 4, which let's use our knowledge of factoring. This factors into x minus 4 times x plus 1. And then you know what? I don't want to forget my factor that I started with, x plus 3. So f of x equals this, right? So using this, we actually have now established another way of factoring, whether it's quadratic or higher order. Yes, you would need to be provided a 0, or you would need to use your calculator to find a real 0 in order to factor the remainder. Make sure you're paying attention to the fact that this said to write it out, find the other linear factors. It didn't say to find the zeros. These are factors, so make sure that you're differentiating between what the question is asking. So I want to go ahead, and you guys have access to the supplemental worksheet, which is great to practice with. And I want to do letter D on this. So if you don't have the worksheet, it's fine. If you haven't like looked at it or printed it or pulled it out, I'm gonna zoom in on D over here, and we're gonna go ahead and do it together, and then hopefully it will jumpstart you to do some of this practice on your own. So here, perform the following division using synthetic division. Is the binomial divisor a factor of the polynomial? So let's make sure we're going to answer that question after. So I'm going to use synthetic division. 4, 6, -8, -12. And then what am I dividing it by? 3 halves. Right? I'm dividing it by 3 halves. Make sure you're focused on the fact that this is a factor. I'm going to use the zero product property to figure out the 0 that goes with that. Okay, so let's bring down the 4. 4 times 3 halves is what, 6? Yeah, which gives me 12. That gives me 18, 10, 15, 3. Well, it gave me a remainder. So is the binomial divisor a factor of the polynomial? No, it's not. It didn't divide evenly. These are great problems as well if you need more practice with long division of polynomials, which is also important to know how to do both. This would be a great thing to practice these that way too and see if you're getting it right? Like I can set it up that way as well. Okay, so we are going to finish up, and so yes, this was a bit of a shorter lesson for me. Go me. So we're going to go back to that warm-up, and let's go ahead and use synthetic division to determine if x plus 5 is a factor. If you remember, it wasn't, but let's do it using synthetic division now that we know it. So I'm going to go ahead and write my leading coefficients. 1, there's a 0, a -13, and a -12. Then I'm going to divide it by -5. Right, so let's draw my line. 1, keep yourself organized. 1 times -5 is -5. That's going to give me -5. 25 is going to give me what, 12? And that's going to give me -60, which gives me, oh, -72. Doesn't that look familiar? Right? Pretty cool. So we would have, what's actually also another way to represent this is I could write, it's not a factor, right? The answer is no, and I proved it again because remainder, that's how far we are out from getting to a whole, is actually equivalent to saying I'm going to take, well, the divisor, multiply it by, what is that, x squared minus 5x plus 12, and then add negative 72. Right, if I were to multiply this whole thing out, another way that I could express it. Okay, right, we can do that. Here, let's see. X cubed, I'm going to distribute the x, minus 5x squared plus 12x, and I'm going to distribute the 5 plus 5x squared minus 25x plus 60, right? And then, okay, so let's add, don't forget that you have that minus 72 there. So then it's going to give you x cubed, those are going to cancel, minus 13x plus 60 minus 72. Oh my goodness, x cubed minus 13x plus, nope, minus 12, right? So it's an equivalent. It's another way of representing this, right? Neat. Okay. So in this lesson, we see, I told you we didn't really use graphing technology. I mentioned it, we didn't really use it, right? You used given information, which yes, that given information could come from your graphing calculator. If I didn't tell you that one of the real solutions is -3, your calculator could do that. In the same way you've generated zeros on your calculator. To identify any real zeros of the polynomial, followed by synthetic division to completely factor or solve a polynomial, right? So we looked at how we use it to factor, and then we also used it to see, to determine if a given factor was a given linear factor was indeed a factor of the given polynomial. So make sure that you get some of your practice in, so go ahead and use that supplemental resource, the one that I shared, as well as working on your homework assignment. And we will be doing work with synthetic division and long division when we see you next. Thanks, everyone.